Friends, how are you? In our previous videos, we have discussed the first law of thermodynamics, enthalpy. In this video, we will discuss the entropy and second law of thermodynamics. Entropy and second law of thermodynamics. As we know that Q reversible over T. This is the differential of a state function. Differential of state function. And a scientist in 1854 Clausius said this state function entropy S for a infinitesimal change in state this law becomes delta S is equal to small change in Q reversible. It is heat of reversible reaction over temperature. Okay, this was our first step. This is the second point. Now we go to the third point. Third point is for finite change in state. This becomes delta S is equal to only 1 times delta S is equal to integration summation Q reversible over T. This is for finite change. Since as we know S is a state function, so it will become equal to 0. Number 4 point is S is the entropy is state function. If it is state function, then change in entropy will become 0. Means this is for cyclic process. Summation Q reversible over T is equal to integration ds is equal to 0 for reversible and for cyclic process. S is a state function. It follows that Q reversible over T is equal to, similarly this thing we wrote again. This equation applies to a cyclic reversible process. This equation applies to cyclic reversible process. All cyclic process are reversible. Right, reversible process. If cyclic process is involving going from A to B and coming back to them, then for entropy change will be if a cyclic process is going from A to B and then B to A. So in this process entropy change will be like this: integration A to B ds plus integration B to A ds is equal to 0. This is equal to 0 because of reversible reaction. Reversible reactions are those reactions in which the products again react to form reactants, change into reactants. So change in entropy will become 0. Now this is become equal to 0. A to B ds plus B to A ds is equal to 0, it will become change in entropy A to B ds is equal to minus B into A ds. This shows that entropy change in going from B to A is equal but opposite sign to that going from B to A. For only then the addition of 2 will be 0. The treatment of dynamic equilibrium reversible process is of great importance in connection with second law. However, in practice, we are concerned with dynamically irreversible process. This all for reversible reactions. In 1854, Clausius extended the entropy equation to the cyclic containing irreversible steps by showing that integration change in entropy Q change in reversible of heat over temperature is less than or equal to 0. Now we will explain this. This is very important, also a short question. This is known as Clausius inequality. After his name, this is known as Clausius inequality. This Clausius theorem is the mathematical statement of second law of thermodynamics. Mathematical statement of second law of thermodynamics. I will explain this integration. Second law of thermodynamics. Now, the cyclic integral, this is the cyclic integral. This is cyclic integral is to be understood by following. Number 1. If any part of cyclic process, if any part, this is a cyclic process and it's some part, if it is irreversible, then inequality applies and cyclic integral will be 0. All irreversible reactions are spontaneous, which forms itself. If any part of cyclic process is irreversible, means spontaneous, then the inequality applies, which is this is inequality applies, and cyclic integral will be 0. Number 2 point, if the cyclic process is reversible, means non-spontaneous, then equality applies. Cyclic process is reversible, then equality applies. Number 3 point, it is impossible for cyclic integral to be greater than 0. Cyclic integral cannot be 0. Will be 0, but cannot greater than 0. As we know, in a reversible process, the temperature of the system will be equal to the temperature of the surrounding. Temperature of the system is equal to the temperature of the surrounding. Means, so our equation will become change in entropy is greater than or equal to change in heat over temperature. Now, second law of thermodynamics has 2 parts. Number 1. Now we discuss the second law of thermodynamics. We explain the entropy. First law of the thermodynamics. First statement of thermodynamics is There is a state function called entropy that can be calculated from state function. Which is state function? That is entropy, which can be calculated. ds is equal to change in q reversible over t. This is first statement of thermodynamics, and second statement is the change in entropy in any process. Change in entropy in any process will be delta S is greater than or equal to change in heat over temperature. When this inequality is applies to a spontaneous process, equality applies. Equality applies to reversible process. This means that in order to calculate the S for change in state, there must be reversible process. The Clausius inequality expression is a fundamental requirement for real transformation. The inequality of so this is the explanation. Equation enables to us decide whether or not some proposed transformation will occur in nature. Thus, now the main statement of the second law of thermodynamics is a definition of second law of thermodynamics. Entropy increases in a spontaneous process. Entropy in an isolated gaseous in an isolated system. Isolated system is that in which no heat exchange, means change in Q is equal to 0. Therefore, delta S is greater than 0 for a spontaneous process. All spontaneous processes are irreversible. This was the explanation of entropy and second law of thermodynamics.